I'm going to try to begin not with the details of science, not with technicalities, but with ordinary meanings and implications of the most important ideas and the most important words in our society, in our literature, in our philosophy, in our art, and in our lives. So science began many years ago with the ancient Greeks with time. Anaximander wrote, all things originate from one another and vanish into one another according to necessity in conformity with the order of time. And for them and for many other thinkers, time has been the fundamental, the only thing in our understanding of nature that's not composite, that's not emergent, that's not in some sense constructed. Time, Anaximander thought, was fundamental to all our experience. But as just mentioned by Mark, that's not the way many of my colleagues, and indeed the way I, until recently, think about time. Albert Einstein, reflecting on the nature of time, wrote, and this was actually in a letter of condolence to the widow of a good friend of his, people like us, we're on page 6, who believe in physics, know that the distinction between past, present, and future is only a stubbornly persistent illusion. So it's not real. In reality, there's no distinction between past, present, and future. And any sense that we have of the crucial difference between how we experience past, present, and future is an illusion. Now, is that really right? And the other thing maybe you might be asking yourself is, what kind of condolence letter was that? Did he really think that his friend's wife would be comforted by that? Would you be? Okay, let's go to the next, and let's go to the next slide. And let's talk about the future from slide 7. And I want us to think about a hypothetical state of affairs in the future. Let's go to the next slide. Say we're all concerned with global climate change. Well, supposing I make an assertion, in 2080, that is in 61 years, the average temperature on Earth will be 6 degrees warmer than now. Now, I'm not concerned, I'm not here to give you a polemic on climate change, although of course we're all concerned that that may be true. I want to ask, what is the status of that assertion? Is that something that we can say now is true or false? Is it true now or false now? Or, going to slide 10, is it in the class of things that is neither true nor false now? And this is a way of saying, of answering Einstein, if the difference between the past, the present, and the future is only an illusion, then if it's a fact of the matter whether the temperature is 6 degrees warmer than last century now on this date, it's just an illusion to think that it's any different 61 years in the future. So if the distinction between the present and the future is an illusion, then it should be a fact of the matter. It should be something which is just true or just false, that the temperature will increase by 6 degrees. Now, this gets mixed up with all sorts of other tricky questions, because we'd like to believe we can influence what the temperature will be in 60 years by decisions that we make now. So if a decision that we make tomorrow or next year could change the temperature 60 years from then, in what sense is the temperature 60 years from now a fact? So these are all different ways of asking the question that Einstein implied. Is time real? We're on slide 12, or on slide 13, or an illusion? And just think about that. To me, and I put it forward to you as a kind of proposition to think about during the talk, this is the question of our time. What is the nature of the future? Is the future real? Is the future not yet real? Is the future determined by what already exists, or is the future open? Those are all different ways of asking, is time real or is it an illusion? Here are some other ways of asking that question. Is truth timeless? Or is all truth true just in a moment. Now, there are many things we believe are true timelessly. The principles of law and justice, mathematical truths, the laws of nature. These are not supposed to be true now and false yesterday and indeterminate a year from now. These are, if they're true, they're just true. But is all truth timeless? Or are there some truths, or maybe all truth, which is just true in the moment? Is what's real and what's true now, just in the moment, to be surpassed or replaced by different truths, which are true in the next moment? Now, there's a relationship between what you think of this question and what you think about laws of nature, if you ever were inspired to think about when you learned in school Newton's laws or Darwin's laws of evolution or Kepler's laws. What is the relationship between a law and time? Now, does time, if laws are timeless, then in a certain sense, I'm going to try to convince you that time is unnecessary. If we have timeless law, which always holds, then whether something is true or not 60 years from now is just a question of doing some computation on some huge computer. And the result, since that computation is something you do now, is logically dependent on what you assume. And therefore, you're replacing the change in the ever-becoming world as it evolves and appears in time with some calculation. So does law emerge from timeless law? Many people write and speak these days as if it were true. Or does law emerge and evolve in time? Is time fundamental or is law fundamental? Again, a different way of saying the same thing that I've already mentioned. Slide 16, is the future already determined or is the future open? Can be changed? Or, to ask the same thing a different way, is novelty possible? If we knew everything about an instant of time, this instant, could we possibly be surprised by what might exist or what might happen a minute from now? Is novelty possible? Now, physics would say no, but let's look into this a little bit. It may seem like I'm changing the subject, but actually these are all different ways of asking the same question. Do our laws apply only to a small part of the big universe we find ourselves in? Are there different kinds of laws that apply to the universe as a whole? Or are laws the same whether applied to an atom or a universe? And to get more personal and go away from the realm of physics and science, here's a question that I'm beginning to appreciate. Do we have more or less freedom as we grow older? Is time real or is time an illusion? What is the wise response to future risks, such as climate change? Is the future determined or is the future open? Now, physics, the way that I was taught it, the way that you were taught it, to whatever extent you studied physics in school, had an answer to these questions. And the answer paints a bleak picture of a world without meaning, without agency. Because fundamentally, in this world that physics describes, nothing happens except rearrangement of atoms according to the timeless law. There can't be any novelty because everything is following the same law and is just a rearrangement of the same atoms. The laws of physics are completely determined, completely deterministic, so the future is already completely determined. Novelty is an illusion, free will is an illusion, the world is just evolving from its beginnings, necessarily following deterministic law. Now, we are human beings. We find ourselves born into this world. We didn't make it. We're trying to understand who we are and what we are here. And it seems to me one of the most important things we know about ourselves is that we have the power of invention. Every child can invent a song that's never been heard before. Every one of us can paint a picture, whether we're amateurs or professionals, that's never been painted before. So it certainly seems like we live in a world full of novelty and invention. But how can that be if we live in the world described by these naive ideas about physics? Now, Tom Stoppard, the great English playwright, in a play called Arcadia, had a character called Thomasina. Thomasina was a precocious student. She had a tutor. This is the middle of the 19th century. And she asked her tutor the following question, in blue there. If you could stop every atom at its position and direction, and if your mind could comprehend all the actions thus suspended, and if you were really, 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 really good at algebra, you could write down the formula for all the future. And although nobody really can be so clever as to do that, the formula must exist, just as if one could. Boy, she was precocious. And that's the question that former answer from physics, that the world is determined, that novelty is impossible, that free will is impossible, raises. Is the entire world codable already in a formula? Or, as Thomasina would say in her present day, I'll skip the first 3 lines, if you had a really, really powerful computer and were really, really good at programming, you could write a program that when you gave it the present positions of all the atoms as input, it would give as output their positions in the future. And although nobody can be so clever as to do it, the program must exist thus just as if one could. And this religion or ideology of the world as a computer, as people as a computer, is to me, and this is perhaps another talk, but I just wanted to drop this here maybe for discussion. This is a dangerous ideology, in my view. And more importantly, it's just simply wrong. It's not remotely justified by the evidence. It's, quote, scientific, but it's a phony kind of science. The worry is that if the whole world, I'm on slide 24, can be exactly emulated by a formula or a computer program, then time is unreal and inessential. This is because causal processes acting through time, creating novelty, creating us, creating the becoming of moment to moment that we experience, are then posited to be equivalent to logical operations or logical relations, and logical truths, if they're true at all, hold true outside of time. So then time is inessential, and the way that we experience the world as creatures of consciousness and agency who can make the future, introduce novelty in every scheme, from ideas to objects that we make, are emulated by something that has no freedom and has no agency. There's a problem here. Now, here's the beginning of how I frame the answer. Thomasina, in Tom Stoppard's play, is thinking about what happens in time, not from the perspective that she naturally has as an agented and willful human being inside the universe, but she's reaching for a transcendent picture of an imaginary perspective outside the universe, outside of time. Because only from a perspective outside the universe, outside of time, that she can imagine the action of this magic formula determining all the future. That's not something that is imaginable if she is part of the world that that computer or that program is supposed to describe. So I'd like to draw a distinction on slide 26 between thinking outside of time versus thinking in time. And if you remember one thing from this talk, it's this distinction, and the kind of, I'm now going to go on to argue that many of the most dangerous ideas of our time come from a fallacious thinking outside of time, and that the correction to them is one way or another to bring time into the center of the picture and think in time. When we think, slide 27, when we think that our experiences in time are an illusion, and what the power of education and argument and ideology to convince really smart, educated human beings that what's most fundamental and universal in our experience, which is that it unfolds in time, moment to moment, is an illusion, and that what is really real is not what we experience, but outside of time. When we adopt that mythology and that ideology, that's when I would like to say we're thinking out of time. And various of my friends and colleagues, like Max Tegmark, Roger to some extent, who I dearly love, and he's my role model above all. And I still have to say to Roger, Roger, when you're thinking that the world is really mathematics, Max, when you're thinking that the world is really mathematics, Sean Carroll, when you're thinking that the world is really mathematics, and it makes sense to say that the world is some frozen vector in an infinite dimensional space of complex numbers, you are thinking outside of time, and you are captive to a metaphysics which takes you far from reality. Now, let's go to slide 30. Some of you will have heard of Sabine Hossenfelder. She's a friend and a colleague. She's a powerful, very good theoretical physicist. And she's also an excellent critic. And here's just a little cartoon break for her commenting on this idea that the world is a mathematical structure. And by the way, let me pause here. I was brought up with this idea. I was brought up from reading Einstein and from the aspirations of my teacher to believe that there was a formula that described the whole history of the world, from Big Bang to Big Crunch. And that my job as a theoretical physicist was going to be to engage in the great endeavor of discovering that formula. And that formula would be a piece of mathematics that would represent the whole universe as a piece of mathematics, as a mathematical structure, perhaps as a solution to an equation or as a geometrical construction. So Max Tegmark tells Sabine Hossenfelder, the whole world, the whole universe is a mathematical structure. And Sabine asks, so he must believe that he is a mathematical structure as well. And she asks, and I am a mathematical structure too. I wonder what it feels like being a mathematical structure. And she's confused. As I am arguing, so should we all, because it makes no sense to say that the world is a mathematical structure. It makes sense to say mathematics is a beautiful tool which helps us to investigate hypotheses about nature, which lets us make models where we can investigate the consequences of ideas. It's a beautiful tool and a powerful tool. We should all have parts of mathematics in our toolkits. But the idea that the world is equivalent to a solution to some equation in mathematics is absurd. One reason why it's absurd is that there's a property that the world has as we know it and experience it that no mathematical equation can possibly have, and that's that it's always some time, it's always some present moment here in the real world. So I claim, this is 35, that this scientific fatalism, this kind of ideology of meaninglessness, and Steve Weinberg indeed commented, the great particle physicist who was a teacher of mine, commented that the more we know about the universe, the more pointless it seems. And what he really meant is that the more we let ourselves be guided by this pseudoscientific ideology based on outmoded ideas from physics, the more we can possibly understand how to even go about searching for a point or for meaning or for a role for intention or belief or love in the world. Now, I worked on this range of problems with a number of people who greatly influenced me. One of them, who we worked together to the present, is Marina Cortez. Another one was Fotini Marcopulo. And the third, who had tremendous influence changing my mind, is a Brazilian philosopher, Roberto Mangueira Unger. And we together came to the view, which is a way out of the traps that I've been describing. And that's that we've found the main fallacy that underlie the wrong direction. The world is mistaken for a mathematical object. And the main fallacy is taking a method of science good for studying parts of the universe and applying it to the whole universe. That is, by construction, the kind of mathematical systems that have been useful in physics, like Newton's classical mechanics, like Maxwell's electrodynamics, like Einstein's relativity, all of these different descriptions of the world require for their coherence that they be applied to just a part of the universe, not the whole universe. And we indeed need different kinds of science, different principles to describe the world as a whole. So now I want to talk a little bit about doing physics in a box. This is when you try to describe not the whole universe, but a part of the universe. In some atoms in an atom trap in a laboratory, some particles colliding in an accelerator. This is when we isolate a part of the world and study it to the exclusion of the rest, and I call this doing physics in a box. Doing physics in a box is what Thomasina was thinking about, and her mistake was applying this method to the whole universe, including herself. And that's the mistake that we claim is being made over and over again. When you do physics in a box, you observe a system from the outside, because you are outside of it, by measuring the positions of the atoms at different times. Then you can write a formula or a computer program that will emulate the motions according to various laws of those atoms in the box. It takes the initial positions as input, and applying a general law to them gives the output, the future motions. But can we put the whole universe in the box? That's slide 39. And the important point is no, you can't. That was Thomasina's mistake, and that is many of people's mistake. Now, in the few minutes that I have left, how can you tell that that approach to science, in which you put the system in the box, and then you extend the box to contain the whole universe, is a mistake? One way to tell it's a mistake is that there are big questions we all want the answer to, that this doesn't answer once the universe as a whole is fallaciously put in the box. For example, we have to specify the laws of physics, but if we're working at the level of the universe as a whole, a new question comes to mind. Why are these the laws and not others? The mathematical tools that we use to describe the laws as best we know them now, general relativity, the standard model, whatever replaces them, string theory, loop quantum gravity, dynamical triangulations, etc., are all invented laws. And as far as we know, nature could have chosen any law at the Big Bang. So this raises this new and urgent question: why and how does nature choose the laws? And laws require initial conditions. A law in physics doesn't tell you what the future will be. For all cases, it says, tell us what the present is like. Tell us where all the atoms and photons are now. And we will use the laws of physics to compute future states of the world. And for that, we need to put in the initial conditions. But when you're describing the universe as a whole, this requires understanding what were the initial conditions of the universe as a whole. See, when you're working in a laboratory, we human beings set the initial conditions. We intervene and we set up the initial conditions, and we test and see what general principles are true for all initial conditions. But when we come to the universe as a whole, we can't do that. We have to ask what sets up the initial conditions. And I think I'm coming close to the end of my time, so I'm going to skip a lot and come to the end. But before I do that, let me tell you the basic idea that I'm skipping over, that I developed with Roberto Manguiber-Unger in generality before in some specific examples, but that indeed goes back to the pragmatist philosophers like Charles Peirce. The only way to understand why these laws and not others, the only way to understand what the initial conditions were in the universe is if they are the result themselves of some dynamical evolutionary process. And it is the search for the dynamical evolutionary processes that are not the laws, but that choose the laws that I believe science should be engaged with. And let me go to 65 and give my thanks to some of the people, the conversations with and interchanges with over many years have helped to form these views. Thank you.
I think it's time now for questions. You can obviously ask your questions in French and they will be translated to Smolin.
By the way, I really apologize that my high school French is not sufficient to talk to you in French. There was a time it might have been, but anyway, let's proceed.
Thank you, Lee, for this talk. I am Mark. If I look at your last slide, I see that you try a rehabilitation of time, but you mentioned that time is the flow of moments, in some sense. But for me, the flow of moments is rather causality than time. So when you speak about time, do you speak about causality or something which is more than causality?
That's an excellent question, Mark. I've become more and more interested in the idea that when we speak about time, we're really speaking about causality. And in the more recent work with Marina Cortez, we've been developing models in order to explore the concept that what we mean by time is really causal processes that act continually to bring the present into being.
Yes, but the concept of time has much more properties than causality, like chronology, simultaneity, duration. So you do not insist to reintroduce all that, it seems.
Our view is that duration, which is related to the measures of time, to the geometry of space-time, among the others, is emergent from the fundamental description. That is, we ask ourselves, what's fundamental? That means that it's a concept that needs to go all the way down to will always be necessary in our fundamental hypotheses about the world. Or if it's not fundamental, it must emerge as a consequence. So to make an example, temperature, pressure are emergent, but in atomic physics, atoms are fundamental. So we posit that, if you like, atoms of causation, moments created or events created from other events by some causal process is fundamental. We posit, these are hypotheses, and other properties of time, like duration, like the notion of the geometry of space-time and everything connected to that, are emergent from a large-scale bulk description in the same way that temperature and pressure are emergent from the collisions of atoms.
Il y a une question en bas, ou là-bas.
Do you think, do you think that we can have more than just a mirror of reality as human beings?
More than, I think it would be really good to be able to get to the level where we can believe we have a mirror of reality. And let me explain what I mean by that. Most of the people who work with quantum mechanics take an instrumentalist or a pragmatic view in which they see quantum mechanics not a mirror of reality, not what, say, a realist would be looking for, a realist such as Einstein or Louis de Broglie, in which they wanted quantum physics to indeed describe the details of each and every atomic process, but which would be what you might call a mirror of that reality. But instead, the anti-realists, such as Niels Bohr and Werner Heisenberg and many people up to the present day, believe that quantum mechanics is a kind of algorithm for discussing the information gained by our interactions with atoms, and has no need of passing the more stringent test of giving a complete description of the world as it might be in the absence of any of those interventions or indeed of our knowledge of it. So as a realist, I'm working hard. It's one of the main goals of the work that I do, is to make a completion of quantum mechanics that might be able to be called a mirror of reality. And my personal belief is that the reason why we haven't gone further with different directions of progress in theoretical physics is that there's a weak leg in our chair, in our table of physical understanding, and that weak leg is quantum mechanics, because it is not, as constructed so far, a contender for a mirror of nature. Was I clear?
Yes.
Good afternoon. Thank you very much for this insightful presentation. This is more probably a personal question, if you don't mind, but what is it that made you change your mind? As you said, at one point you changed your conception about time. Was this like after an physics experiment, or is it an intuition? I'd be interested in knowing what triggered that.
It was actually the congruence of three different things. One of them was technical, that is within the work that I was doing in loop quantum gravity with Carlo Rovelli, Abayash Tikar, and many other people. We had a schema for how time should emerge from timeless equations. And we had solutions to those timeless equations, indeed. And there were technical details that were persistently not working, were stubbornly not working. And that concerned me. At the same time, I knew of work done by other people, some of them also friends of mine, exploring modifications or different formulations than loop quantum gravity. And they found that if you assume that time is fundamental, you can get space and space-time to emerge. But if you assume that neither time nor space is fundamental, nothing actually emerges from the calculations. And I'm thinking here of Fotini Marcopoulou and Renato Lowell and Marina Cortes, who all had different models in which you could see that space and space-time would emerge if you put time in and declared it fundamental. And the third thing was my encounters with Roberto Mangiavera Unger. In particular, I had another line of work connected with the question of what shows the laws of physics. And this was brought to my attention by friends who were working in string theory, particularly Andy Strominger, who were concerned that with the vast numbers of different string theories, it would be impossible to have the usual interaction between theory and experiment that constrained theory, because whatever the experiment saw, there would be a version of theory that could mimic them. And because of that, I developed a hypothesis or a scenario about how the laws of physics might evolve on a kind of something you might use the metaphor of the fitness landscape from biology and physics and call it a landscape of theories. And I had a process, as I was describing before, for dynamical evolution of laws on this landscape. And in it, time, of course, was fundamental, because if laws are evolving and changing, they're evolving and changing in some prior notion of time, which doesn't depend on emergence from the laws, which are, if you like, just emergent. And when Roberto and I began talking to each other, he either said to me, or just the memory of the first conversation with him spoke to me. And what I heard was, sort of, what kind of fool have you been, have I been? Because I have these two parts of my work, and one of them I depend on the idea that laws emerge from a world where there's fundamentally time and change and causation. And in the other, my work in quantum gravity, I'm following an orthodox point of view with my friends there, in which we assume that the laws are timeless and time emerges from the action of those laws. And I felt acutely the contradiction between the different parts of my own work, and took a long walk in New York, and that's when I experienced this strong change of mind. Does that help? I mean, there's all sorts of considerations and things that happen, but I think that the essence of it wouldn't, any one of those three influences by themselves might not have been sufficient, but I felt strongly the three of them together, and they happened within the same, I knew about them within the same few months. And then it was, sorry, go ahead.
But hold on, aren't you contradicting yourself? Were they all out of the box thought process, as you described earlier? The three ones you just described now.
Well, I was thinking of quantum gravity naively as a potential theory of the whole universe. So I was trying to make models, as were and still are a number of people, in which you think of the whole universe as described in the quantum geometry that loop quantum gravity describes. So there was a contradiction, of course, and I came to this rather different point of view as a result of fully appreciating the contradiction that I've been working with. There were other things that my interest in the foundational problems of quantum mechanics played a role too, because there was a different line of thought that led to taking the notion of time more seriously. But that wasn't the dominant thing. The dominant thing was the confluence of those three issues. And of course, there were contradictions. And, you know, contradictions are, one speaks as if, oh, there's a contradiction, we all experience it, and it's acute, and how could we possibly live with it? But in my experience, the most insidious of contradictions, both on the personal level and on one's work, one's creative work, are there in plain sight for somebody to see, but for yourself, you become accustomed to this place in the apartment where you just have to walk around this hole in the floor and never fall into it. And after a while, you don't see the holes in the floor, but you manage your daily life nonetheless. Contradictions persist because they're invisible to us. And that's the way in which, that's one reason I'm such a promoter of diversity and of ideas and diversity of people in science, because it's the outsiders, whether for reasons of intellectual roots.
Can you hear me?
Yes.
I'm sorry, but we are out of time. I'm really sorry. So I have to, we have to conclude the session.
Okay.
Do you want one last word?
Yes, it's the outsiders in all senses who see the contradictions that the rest of us miss. And that's why it's necessary to include them.